you, ma'am. The topic is the climate commitment, phasing out of coal-based units with renewables. The previous speakers, Mr. Ravi Chaudhuri of CSC and Ganapati Chaudhuri, he had set a right perspective of the background for this particular topic. And phasing out may not be the right term. It should be phasing down of coal-based units. In this presentation, I will touch upon the doables of coal-based thermal units in view of these large-scale integrations of renewables. And I will touch what should be our process, how we should approach it, and how we should acclimatize it mentally, and we have to absorb the necessity of doing it, the flexible way of operating our plants. Now, if we see the climate commitment, our previous speakers have touched upon, but I just touch upon these points. India's commitment in COP26 was India will bring its non-fossil energy capacity to 500 gigawatt. Now it is 104 gigawatt. It's a huge jump. India will bring its economy's carbon intensity down to 45% by 2030. Very, very ambitious. India will fulfill 50% of its energy requirement through renewable energy by 2030. And the last but not the least, the most important, net zero emission by 2070. So this is the background. And what we have achieved so far, we have achieved 40% of installed electricity capacity from non-fossil fuel. It is also very important. 104 plus hydel capacity taken together at around 150 gigawatt plus. That is the capacity what we have already installed. Now, if we see the two charts in 2021, 31st December, we have a capacity of 392,017 megawatt of plant all over India, where 53.4% is coal, and solar and hydro and wind together coming around 40%. So that is the point. The renewable energy, we consider hydro also into it. And if we see the right side, the 2930, in a 10 years period, we'll have a total capacity, projected capacity, 817,254 megawatt, and out of which coal will be around 32.7% odd, and solar and wind will take a huge chunk. So that is the target. So the challenge is solar and wind is highly unpredictable and sort of intermittent nature of power source. So we cannot depend entirely on the solar and wind unless and until there are some energy storage technology innovations will take place in future. So we have to have some other mechanism of power sources. That may be coal, that may be gas, that may be other way, say biomass and others. So that is the situations right now. But in Indian context, because we do not have sufficient capacity of hydro and gas is not available, so we are heavily dependent on coal, and we will depend on coal in future time also. So this is a particular classical chart. It is given in our recommendations given by a Central Electricity Authority report, where it is shown that on a given sunny day in the month of, say, July, August, where the RE power is at its peak, the both wind and solar generally generates maximum during that rainy season. Now, on a particular sunny day, if the solar power is at its peak, then the orange line, what it is shown in the in between, which will reach at peak in the 12 hours in the during noon, and during that period we have to keep our coal generation, which is shown in a black curve, we have to keep it down, so to manage our total energy demand. So the point is, maybe in the 7 o'clock in the morning, we have to reduce our coal generations, ramp it down, and keep it as minimum as possible during 12 or 13 in the noon time. Again, we have to ramp it up. So that is the classical dark curve. And given that particular curve in mind, what are the doables for coal plants? We have to ramp it down and again ramp it up. We have to make the unit run at a lower minimum load, and in the process, some of the plants having a lower capacity, maybe 150 megawatt and less, some of the older plants, old inefficient plants, are to be retired or subjected to two-shift operations. And third component is essential, the provision of at least 55% technical minimum load. Okay, even now, our central generating stations, ISGS stations, they are operating at 55%, but still some of our state GENCOs are operating at a higher percentage of loading factor, so that these challenges will be further intensified if they do not come down. So that is the point CA had mentioned in the report. Now, to adapt to these situations, to acclimatize with the flexibilizations process, what we have done so far in NTPC, that we have taken a trial operations in different units so that our people are well trained, mentally adapted to this flexibilization process in front some of our international experts like German experts, GE, our USAID, all those agencies. In front of those agencies and experts, we have taken some of the trial operations for minimum loading operations and with the higher ramping. Even we have taken the support of J Coal in case of our Vindhyachal unit. So we have taken a series of demo sort of trial operations in front of those expert associates. And from that, we have learned a lot. And EPRI USA, that is, they are also pioneer in sort of a consultant sort of agencies where they have given us a sort of benchmarking studies where we have identified the gap and intended O&M practices required to follow because of these flexible operations. So these are some of the studies we have done. And from those studies, what we have observed that during these minimum loading or flexible operations, we can face the challenges of the flame stability, because when the unit will run at say 40% load, then with the coal conditions, the coal what we are firing in Indian conditions with the lower GCV and sometimes very low VM coal, the combustions and flame stability will be a great challenge. That is the first challenge. The second challenge is when the units are running at lower load, the steam flow through the boiler will be less. It can be subjected to high heat load, and as a result of that, the boiler tip failure can occur. When the units are run at a lower load, the draft power will be less. As a result, there may be a chances of ash depositions in the boiler pressure parts areas. And taking all those things in mind, there will be a crisis of process control. The process control with respect to the temperature variations, with respect to parameter variations, metal temperature variations. So those are to be controlled. And the variations of coal quality, sometimes we are facing the challenge that the coal what we are receiving are varying in nature. And finally, the thermal fatigue. So these are the challenges we have faced during that trial operations. And from that, if we convert it into some of the parameter terms, then I am a little bit technical, but please excuse me, because it is the WPDCL, the same generator fraternity I am talking with. So that is why I am touching those points in to some extent greater details. The excessive fluctuations in steam temperatures, the high drum level swings during ramping, the flame disturbance during ramping and minimum load operations, occasional furnace pressurizations, sometimes the stalling of PFNs, and low boiler flue gas exit temperatures, which can lead to acid corrosion if it is maintained like that. So these are some of the critical areas we will face when we run the units at minimum load. Now, just giving you some overall perspective. This is a particular study taken in Mouda, where when the units are running with the 500 megawatt units running at 6 mils operations, the flame scanners positions are like that. But when we come down to 40% load, we cannot run the unit at 6 mils, of course. We come down to 44 mils, even below that, 3 mils. Now we have run with the 3 mil conditions, the flame will be shown like that. Though there are some reduction in flame intensity, and this is a huge challenge. Then in Talcher, we have taken the trial operations, where we have observed that the main steam and HRH steam temperature, the fluctuations is huge. It should not be more than, say, 8 to 10, 12 degrees centigrade, but it is more than 20, 25 degrees centigrade. And during that ramping and lower load operations, our metal temperature are also crossing the limits. So these are the areas where we have to take control. Drum level fluctuations in the case of 500 megawatt units, the TDBAP recirculation valves, the on-off type is very difficult to handle when the units are running at a lower load. Sometimes it is closed, and as a result, there may be huge fluctuations. And of course, at a lower load, the primary air fan can lead to a situation where the fan can be stalled. So these are some of the critical aspects what we have observed during that particular trial operations. And finally, the solutions, what we can think for to eliminate all those situations are some of the control, which is predictive type. The main steam temperature control in classically whatever available in our units are basically reactive type. That means when the temperature goes high or goes down, then only it is controlling through spray or other mechanisms. But the predictive steam temperature, it will predict, sort of machine learning applications will be utilized, and based on the previous trends of temperature rise, it will control proactively. So that sort of advanced process control is to be introduced to control those steam temperatures. Similarly, the reheat temperature also. The installations of modulating type recirculation valves are also being deployed in BAP to avoid that drum level fluctuations. The milling system is very, very critical. As we have explained, the type of coal we are handling, the variations of coal, and the number of milling operations are to be optimized, because of otherwise there will be a skewed primary air to secondary air ratios, and that will create a problem in combustions. But to eliminate that, what we can do, we have a solutions like automations of milling and mill schedulers. That means the mill scheduler will decide in which mill how much coal is to be loaded based on the different parameters, combustion parameters inside the furnace, and accordingly run those mills. So that is the mill schedulers, what we have, that may be the best solutions to deal with those situations. Similarly, the flue gas temperature control, the boiler exit temperature control, and where the SCAF can be handy. So when we come down from, say, full load, 500 megawatt full load, to technical minimum load, say at a 40% level, 200 megawatt, at a ramp rate of 1%, then if we can have a automated start, stop, ID, FD, PA, and milling automations, then we can have a seamless operations, because the human interventions or human interventions during those process will definitely jeopardize the entire process systems. And another point I'd like to mention here, that we are installing boiler fatigue monitoring and equivalent operating hours in turbine to see how this ramping and lower minimum load are affecting our plant life. So these are some of the solutions, and based on our trial operations. And in Simadri also, we are utilizing some of the advanced process control, where the applications are limited only with respect to temperature, with respect to the unit load response optimizations and combustion optimizations. So they are basically through process control we are trying to manage at Simhadri. And this is a flow chart I would like to tell before you all as a generator what are the three basic essential elements involved. The first is people, because we have to adapt to the situations. The first and foremost is creating mindset, accepting the fact that we have to come down to a bare minimum load, accepting the fact that we have to run the unit for a 500 megawatt unit with 3 mil operations. So that is a change in mindset. And for that, what is required is the exposure, the trial operations, and training to the people. The second, the process. The most and important fundamental aspects of dealing with this situation is the process control, advanced process control, which is to some extent proactive type control. And third, the technology, maybe new technology like automations of mill schedulers, some other engineering applications. When we conceive during the design stage, there may be changes in technological interventions may also be very much handy. So these are three different criteria through which we can control the flexible operations in our thermal plants. Now, at the end, I would like to conclude by 4 key points. The first point is coal-based units are to be flexibilized. There is no other points. Our previous speakers also told categorically. What are those? The minimum load may be 40%, high ramp rate, and frequent startup. So these are the 3 essential elements of flexibilizations. The third is there will be cost associated with flexibilizations. The part load degradations, when you run the unit at lower load, our coal consumption will be more and there will be degradations. Our startup cost because of frequent startup and shutdown, then life consumption cost due to this flexing. And all those costs are to be adequately compensated to the generators. Otherwise, a generator cannot go for these flexible operations. So the third step is plan and prepare. Prepare for the competency development, introduce advanced process control and new technology interventions to minimize the life consumptions. The life will be consumed because of variations in temperature, because of fatigue and creep associated with those operations. Then last but not the least, the other speakers had also categorically told that at least for another 2 to 3 decades, the coal units will stay here. This is for sure. So we have to adopt it. We have to welcome it and we have to acclimatize it for the better flexibilizations of coal-based unit to accommodate larger and larger integrations of renewables. Thank you so much.